Okay, Assalamualaikum and very good morning to our lecturer, Miss Sumaiya Binti Mashori. Okay, today our group will explain to you our group projects for subject Programming and Application Laboratory PLC BND 32103. We are from group 2. Okay, for task projects, for activity week 13, this for the group project, we must submit a video presentation to summarize for our standing of subject PLC that have been covered for the whole semester. Okay, there are four elements. First is photo of group members. Second, the specific task done for each members. Third, an activity done for the whole semester. Fourth, the suggestion or comment for teaching and learning improvement. Okay, next is group members. Okay, first me, Mohamad Aiman bin Zahazunizam. Matric number DN180058. Okay, next my friend Muhammad Hidayat bin Halim. Matric number DN180051. Okay, next member, next friend is Muhammad Afiq Zulhelmi bin Karim. DN180019. Okay, next is the specific task. Okay, the specific task done for each member. Okay, me will explain to you about week 5. Okay, Muhammad Hidayat will explain about week 4. And Muhammad Afiq Zulhelmi will explain about week 3. Okay, this is for activity for the whole semester that have been provided by our lecturer. Okay, there are 14 week. Okay, this activity week 5. Okay, first of all, in week 5 there are 5 questions. Okay, first question is about direct control. Okay, and the question is about start button is used to start a motor, and stop button is used to stop the same motor. Okay, assume the normally open contact is for the start button and stop button is normally close contact. Okay, when we push the start button and normally open will close the contacts and power flow will through the normally close contact for the stop button and the output will on. Okay, when start button is released, okay, the power cannot go through the normally close contact and the output will off. This because when stop button is pressed, the normally open contact will open the circuit and de-energize, so the output still off. Okay. Uh, okay, next question is still the direct control. Okay, for we just modified the ladder diagram in question 1, so the motor should continue to run even though when the start button is released. Okay, so you just modify when even the start button is pressed. Okay, the current will go through the normally open contact will become normally closed contact, and power will flow to the normally closed contact and the motor will on. Okay, when start button is released, the normally open contact will open the circuit, but the energies of normally open contact for motor right here will keep the motor on. Okay, next, when the stop button is pressed right here, normally open contact motor will de-energize and output will off. Okay, so the third question is about direct control also. So we must modify the ladder diagram in question 2 using set and reset instruction. Okay, set is about triggered bit on if education condition is on. Okay, reset is trigger bit off if education condition is off. Okay, when the start button is pressed, the normally open contact of start button will close the circuit and turn the operand bit on. So when start button is released, the normally open contact of start button will open right here, but the operand will keep bit on. This because the execution condition is on, so it does not affect the operand even the start button is released. So when the stop button is pressed, the normally open contact of stop button will close the circuit and turn the operand bit off. Execution is on and the output will off. This the reset. So the bit triggered bit off is execution is on. Okay, right here the fourth question is about using the self-holding indirect control dominant off. Okay, this what is different indirect and direct control? Okay, indirect control, there are IR1. IR1 is called internal relay. Okay, in direct control there are no IR1. Okay, so there are different indirect control and direct control. Okay, indirect control there are also two dominant. One is dominant on, one dominant off. Okay, what is different dominant on and dominant off? Okay, dominant on, when the start button and stop button is pressed simultaneously, okay, the output will on. And dominant off, start and stop button is pressed simultaneously, the output will off. That's a difference between dominant on and dominant off. Okay, so in this question, when the start button is pressed, normally open contact will close the circuit and power will energize the normally contact of IR1. So this IR1, so will energize this IR1. So through the normally close contact of stop button, the output will on. Okay, even when start button is released, normally open contact of start button will open the circuit, but the energize of normally contact of IR1 will go through the close contact stop button, then output will keep on. So when stop button is pressed, the normally open contact of start button will open the circuit and the normally open contact of IR1 will de-energize, so the output will off. So when start button, this about dominant off. So when the start button and stop button is pressed simultaneously, the normally open contact of start button will close the circuit and power will go through and the output will off. So what is different between dominant on and dominant off? So when the dominant off, we press the start button and stop button simultaneously, so the output will off. Dominant on, we press the start button and stop button simultaneously, the output will on. So that's the difference. Okay, next, last question in week 5. Modify the ladder diagram in question 2 using the keep instruction. Okay, what is keep? Keep is called latching. Okay, so this is a ladder diagram. So there are two input, start and stop. So when start button is pressed, the normally open contact of start button will close the circuit. Okay, and power will go through to keep and energize the IR1, so the output will on. Okay, when the start button is released, the normally open contact of start button will open the circuit, the energize of keep will energize the IR1 and output will keep on. This situation we call the latching. Even though we release the start button, the output is still on because the instruction in keep the instruction before. So next, when stop button is pressed, the normally open contact of stop button will close the circuit and the power will go through. So the normally open of IR1 will open the circuit and the output will off. Okay, when the start button and stop button is pressed simultaneously, the normally open contact of start button and normally open contact of stop button will close the circuit, and power will go through and the output will off out. This we call the dominant off.
Okay, last but not least, okay, suggestion or comment. Okay, suggestion for comment for teaching and learning improvement. Okay, in my opinion, even given the current situation that cause online learning, uh, pandemic COVID-19, class should be done in laboratory, but the lecturer was still able to convey the knowledge well, and I was able to understand it well. So I hope after this pandemic COVID-19 is over, I hope I can join the class in the in the laboratory, so to be more practical. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Hidayat bin Halim. So today I would like to tell you about an activity that have been done throughout the whole semester. So from this we can see I choose week 4 for the example for the activity for the whole semester. As we can see, first of all, we learn about how to do the ladder diagram, basic logic function, and ladder logic instruction in this topic for week 4 outcome. Okay, first of all, this ladder diagram commonly used to document industrial control logic system called ladder because they resemble a ladder with 2 vertical bus bar, power supply, and as many rungs, horizontal lines to represent the control circuit. As we can see, this number is we call rung. Okay, and for this we call step number. Okay, the setting for PLC we use on CP1E. Okay, we can see the input we use the range from 0.00 until 0.11, and for the output we use 100.00 until 100.07. How to calculate the step number is we can first of all we calculate like this. From here, this 1, 2, 3, 4, and next 5, 6, 7, 8, 9, 10, 11, 12. This is the way to calculate the step number. As you can see that this input is used power supply exact 24 volt and the output is 0 volt, and this middle is the interface and the last is the output. Okay, next this is the basic ladder logic instruction. As we can see that this example is for the LD, and this you can see that the slash is for the LD not. And we see here and not is why because this circuit is in series, and not because this one this one circuit have not gate, and this is N because the two things that have no slash, so we call it N. This is the parallel connection for O. O means that the connection must be like this. If series, the connection just straight through. As we can see, this for the O not, because one is not and one is the basic lah. And this is for the OLD, and the bottom is an LD, and this last is for the output. Okay, for the basic logic function, this is the example of AND gate, and the below is the for the AND gate. So we solve by this problem by we create the ladder diagram for the AND or gate, and then we do the mnemonic code. First of all, we do like this. This is for A, and this is for B, and this is for the output. This is 24 volt supply. Okay, for the mnemonic code, we can solve it by, for the first is LDA, and for the second is N B, because the circuit is in series. And for the output, and lastly for the output cycle, and for the second is OR. OR means that the circuit is in parallel, so we solve like this. Okay, this for A, and this is for B. Okay, and this is for the output, CY output side. Okay, and to solve it, we set LDA, and then because it's in parallel circuit, we use OR B. Okay, for the output, we just put output CYL. Okay, like this. Okay, for next is for the NOT gate and NAND gate. For the NAND gate, we use like this. NOT gate, use NOT, and this will be the output. Okay, this is for E, this for the output. For the mnemonic code is LD NOT, and then out. Okay, for the AND gate is like this. Okay, yes. So we solve it like this. LD, this is for A, and this is for B. LD not A, and then O not B, and then out. Okay, this is the for the solve for the mnemonic code and for the ladder diagram. Next is for the basic ladder logic instruction. First of all, we see the round. This is the round. We use just only one round, so we set 1, and then for the step number, we set this for 0, 1, 2, 3. Okay, set for this number 0. Instruction is LD, and the operand is 0.00, and the comment for this K. For the step number 1, this is for the out, and the output is 100.00. This is for the output LO, and for the second is LD not 0.01 L. and for the lastly 3 out 0 1.0.1 for the and 1. Okay, this is how to solve for this ladder diagram. And next is we solve the in parallel circuit. So first of all, we use one round, so we set 1 for the step number 1, 2, 3. Okay, first of all we set 1 is LD. Okay, operand 0.08 and the comment is G. And for the my mistake, this is the 0, 1 and 2. The step is 0. Okay, this is for the 1 is N because interval and LD. If you use N, it's also okay. 0.09 ish. And lastly, for the output is 2 out 100.05. This we put is L5. Okay, that's it. Okay, for the specific task that we have done for each member is my part is editing video and compiling the video. For the suggestion and for the teaching and learning improvement, I have 2 points. My first point is the teaching method that the lecturer gave was very good and give many example for every question and solution. For the second is the student need to do more exercise and focus on the subject continuously in order to catch up with the subject, because this PLC subject need to do exercise instead of only just to understand. We have to need to do exercise a lot. Okay, thank you.
Okay, for the week 3, we have done activity 2, that is we have to familiarization with PLC Omron, CP series, CP1, CPU units. For the introduction, PLC or programmable logic controller have gone through an industrial controller application because of the step to create a controller, is of programming, is of wiring, is installation, and is of changing. There are many different players in the PLC market, such as Allen Bradley, Siemens, ABB, Mitsubishi, Panasonic, Mohamad, and Cassandra. A basic PLC system consists of input or output section, CPU, that is central processing unit, programming device, power supply, and memory. So this is the programming PLC. As I mentioned earlier, that have input, output, power supplies, programming device, program data, memory, that is memory, and CPU. So we have been given that 2 PLC model. So we must identify the PLC model and fill in the datasheet. Okay, so in the datasheet, there are 2 models. That is first model for the A is CP1E E2OSDR-A. The second is CP1E-N2ODR-A. Class is E basic model, input output capacity, unit type, built-in, input type, output type, and power supply. Okay, they have different feature. First, none the analog adjuster PV in A642 or A643 is fixed on 0000. They have 2 analog register that is series 02255. So now this is the system configuration A for the A. Software programmer and input output connector cable, special input output unit, and so on. So this is the system configuration for the B. The second type that is the CP1A and 2ODR-A. Here we have given that this model number structure. So we must fill in the sheet. We must fill the data sheet for the model number, programming language, instruction execution time, overhead processing time, working capacity, input output address, work area, coding area, temporary relay area, temp area, and control area. Okay, for the data analysis to in that week, that is week 3, we have must analyze test 1 and test 2, focusing on different feature, basic model, application model, and CP1E series consists of. Okay, for the analysis, from the task 1, we need to identify and know the type of model. From the task 2, we need to fill in the blank for the PLC CP1E training kit datasheet. From the datasheet, we can see that they are different in programming capacity and data memory capacity between two models, which is CP1E and 2ODR-A and CP1E-E SDR-A. The similarity we can see is from the programming language that the bots model use slider program. Okay, for the discussion, you must understanding the basic model structure is important to avoid any problem that can occur ahead. Some device can give different output. So PLC have their own function of feeder. And in order to make it work, normally we have to know the application and the general characteristic of the device. They are different between basic model and application model. So the conclusion, we know that the basic knowledge of understanding the model, structure, and function is taking role in every activity involved. Make sure to follow datasheet for each model to ensure the best device that can be used and work accordingly. Okay, for my suggestion and comment in this subject, I suggest that in this subject, the learning of the subject must be in class that are face-to-face, not by online. So if the class are doing by face-to-face, the student will understand the subject of PLC thoroughly. Thank you.